Every app needs secrets, database connection strings, API keys, signing certificates. The naive answer is to drop them in an environment variable or an app settings blob. But that just moves the problem. Now your secret lives in source control, in your CI pipeline logs, and in 3 engineers' laptops. This is the secret zero problem. To read a secret, you need a credential, but where do you store that credential? In this video, we dissect one reference architecture that breaks the chicken and egg cycle, Azure Key Vault plus Managed Identity. We'll walk the token flow, the trust model, the failure modes, and the trade-offs an architect actually weighs. Here's the design. A workload, say an Azure Container App or App Service, is assigned a managed identity. That identity is a service principal in Microsoft Entra ID that Azure manages for you, with no password you ever see. Key Vault holds the actual secrets. When the app needs a secret, it asks the platform for an Entra token, then calls Key Vault with that token. Key Vault checks its access rules and returns the value over TLS. The crucial property: there is no bootstrap secret anywhere in your code or config. The platform injects the identity at runtime. Let's trace one request step by step. The app's runtime hits the Azure Instance Metadata Service endpoint on a linked local address, asking for a token scope to vault.azure.net. The platform, holding the identity's credential, returns a short-lived JWT, typically valid about 24 hours. The app then sends an HTTPS GET to the vault with that bearer token. Key Vault validates the token's issuer and object ID, checks authorization, and returns the secret value. The SDK caches the token and refreshes it before expiry, so most calls never touch Entra at all. You choose between 2 managed identity types, and it matters. A system-assigned identity is tied to one resource's lifecycle. Delete the app, the identity is gone. It's simple and great for a single workload. A user-assigned identity is a standalone resource you create once and attach to many workloads. Use it when several apps share the same access, or when you want the identity and its role assignments to exist before the app is deployed, which avoids a deployment ordering problem. Rule of thumb: start system-assigned. Move to user-assigned when you need to share identity or pre-provision permissions. Authorization is where teams get sloppy. Modern Key Vault supports Azure Role-Based Access Control, RBAC, which I recommend over the legacy access policy model because it's consistent with the rest of Azure and supports fine-grained, scopable roles. Assign the Key Vault secrets user role, which grants read-only on secret values, not the broad administrator roles. Scope it to the vault, or even a single secret, not the whole subscription. Here's the bicep: a role assignment binding the app's principal to that built-in role at the vault scope. Check current docs for the exact role definition IDs, since these are stable but worth confirming. No design is free. Think through what breaks. Key Vault enforces throttling on the order of 2,000 transactions per 10 seconds per vault. So an app that reads secrets on every request will get 429 errors at scale. Fix it by caching secrets in memory and refreshing on an interval, not per call. A second failure mode is the cold start latency of the first token plus vault round trip, usually tends to a couple hundred milliseconds. Third, regional vault outage takes your app down unless you replicate. And if you delete a vault, soft delete and purge protection retention can block you from reusing the name for 90 days. Design for these, don't discover them in production. The whole point of centralizing secrets is rotation. Key Vault versions every secret, so writing a new value creates a new version while the old one stays valid. Pair this with Event Grid. Key Vault emits a secret near expiry event. A function rotates the credential at the source. Say it generates a new storage key and writes the new version back. Your app, refreshing its cache, picks it up automatically. For platform integrations like App Service, Key vault references resolve secrets at startup, though be aware those refresh on restart, not instantly. So for hot rotation, prefer reading through the SDK with a short cache. Let's tie it together. Managed identity removes the bootstrap secret entirely. Entra issues short-lived tokens. Key vault stores values and enforces RBAC. Caching protects you from throttling. And versioning plus event grid gives you rotation without downtime. The one concrete action to take this week. Pick your most secret-heavy app. Assign it a managed identity. Grant the key vault secrets user role scope to a single vault. And delete one hard-coded connection string from its config. That single change removes a real credential from your repo. Pricing and role definitions shift, so confirm the current Azure docs before you finalize. Thanks for watching. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.